Good morning, folks. It is Monday, June 1st, um, getting towards the end of the school year. We have two more assignments, one this Monday today, and one next week, which will be June 8th or June 10th, depending on whether you're A or E block. I want to thank those of you who completed the survey last week. It was very, very helpful to me to have that survey. I shared it with Mr. Landers and Mr. DeBurn. But one thing that came out of that is that you like having videos that I create that show you the stuff that I would be doing on the board, but also that you're really missing the ability to ask questions. And a few of you, maybe more than a few, suggested to have a once a week Zoom class meeting just so that you have a chance to ask questions. So we'll do that on Friday of this week. Better late than never. If you would like to, it's optional, but at 11 o'clock on Friday, I will host a Zoom meeting, and the purpose will be to answer any questions that you might have about series and parallel circuit diagrams. Your last assignment for next week will be a quiz on series and parallel, a 10-question quiz. There won't be a final exam this year. Probably you already know that. And so what I'm going to do today is a few examples, as I did last week, a few examples of how to use Ohm's law to solve a series circuit or a parallel circuit, how those two different circuits are similar and different. And you'll have some practice with that this week. And then Friday, you'll have a chance to ask questions. And then next week, you'll have a quiz. And that'll bring us to the end of physics. All right. I hope you are continuing to be well in your homes in Longmeadow. I'm continuing to be well next door to Mr. Walker here in Florence. And so I'm going to flip my tablet down, get rid of my face, and do some examples. All right. So if you're doing this with me, just have a calculator with you because I'll be using that calculator. Okay. So a little bit of noise here. So I'm going to be drawing some circuits and trying to solve them using Ohm's law. So let's remember what Ohm's law is. Ohm's law says V is equal to I times R, or another way to write it as I is equal to V divided by R. Ohm's law. We also have a power equation. Power is equal to current times voltage. So those are the three formulas that we're going to be using as we solve our circuits. And let's start with series circuits. And I'm going to line up a battery. Maybe I'm going to use a few batteries. 1, 2, 3 batteries. Some devices have 3 batteries in them. And let's do 3 resistors in series. In series means one after another. All right. And I'm going to say this is R1, and this is R2, and this is R3. Let's give ourselves a 24-volt battery. So I don't know, how do you get 3 batteries to be 24? 6 and 6 and 6. Nope, I need one more 6. So 8 and 8 and 8 volts connected together would give me 24 volts. And let's make these resistors, I don't know, let's do 100 ohms, 200 ohms, and how about this 300 ohms? Okay, so here's the thing about a series circuit. Current is actually set up in the entire wire. So these 3 resistors are connected by wires. If we were doing this in the lab, we would actually be connecting these light bulbs with wires, and the electrons are found in the wires. And so as soon as you connect the wires to the battery, the electrons everywhere start moving. They don't necessarily come out of the battery and flow around like you might think. They actually start moving everywhere at once. But it's okay to imagine the current coming from the positive side of the battery, going through the first resistor, through the second resistor, and through the third resistor, and then back to the battery where it gets its energy. All right, so current is flowing in that direction. Notice that there is only one loop for current. There is one loop. Current never has a chance to branch. There's not any place where current splits off. So in series, current has only one loop. And that means every single resistor gets the same current. All resistors. And the battery get the same current. That is true in series. All right, that is true in series. It's not true in parallel. All of the resistors receive the same current. The battery provides that current, and current is the same everywhere. The thing that's different for each resistor in a series circuit is the voltage. And so the battery provides 24 volts, but the voltage from the battery is shared among the 3 resistors. Voltage from the battery is shared among resistors. So if the first resistor gets 10 volts and the second resistor gets 10 volts, well, then that means there's only 4 volts left for the third resistor. They have to add to 24 volts. And we're going to use Ohm's law to figure out how much voltage each of those batteries takes. Okay, so these are the facts about series. Different for parallel, but that's what's true for series. Okay, so those are some things to keep in mind. The thing to remember about resistances in series is that to get the total resistance, you simply add them up. R1 plus R2 plus R3. And if I add 100 and 200 and 300, I get 600 ohms. Okay, very simple and straightforward. So then the next thing to do is draw this 3 resistor circuit as a simple circuit. Simple circuit has 1 battery and 1 resistor. Okay, 1 battery and 1 resistor, where my total resistance is 600 ohms and my battery is 24 volts. Okay, so now I can use Ohm's law to find that current. I is equal to 24 volts divided by 600 ohms. And what do you get on your calculator? 24 divided by 600. I get 0.04. 0.04 amps, which is the same as 40 milliamps. All right, there's my current. Everything gets that same amount of current. So now if I go backwards to my original, and maybe I'll do that down here since this is pretty messy, I'm going to just redraw that. Don't be afraid of drawing lots of pictures in physics. I always encourage that. R1, R2, R3, 100 ohms, 200 ohms, and 300 ohms, and 24 volts. Okay, so now I have the current of 0.04. 0.04 travels everywhere. 0.04 I is equal to 0.04 amps. Okay, that means the current through resistor 1 is 0.04 amps. The current through resistor 2 is 0.04 amps, and the current through resistor 3, 0.04 amps. I could even say the current through the battery is 0.04 amps. Now, what do I do to get the voltage? If I were going to measure the voltage from here to here with a little voltmeter, little meter with a V, that means voltmeter, what would V1 be? Likewise, if I wanted to measure the voltage from this side of the resistor to this side of the resistor with a little voltmeter or multimeter, what would that voltage be? What would V1 be? What is going to be V2, V3? We already know the voltage across the battery. It's 24 volts. That's all the battery has. So how can I find V1, V2, and V3? Well, we've got Ohm's law, right? V is equal to IR. V is equal to IR. I know the current, and the resistance here is 100 ohms. So if I take I1, 0.04, and I multiply it by the resistance, 100 ohms, I think I'm going to get 4 volts. Okay, what about V2? V2, I know the current, 0.04 amps. I know the resistance, 200 ohms. That's going to give me what? 8 volts. And V3, 0.04 amps times 300 ohms. I'm thinking that should give me 12 volts. And if I add those together, 12 plus 8 plus 4, do I get 24? Yes, I do. So I've solved that correctly. That's your check. Okay. The last thing that I'm going to ask you to find is how much power is the battery putting out? Power. And I'm going to use a little subscript of B to mean the power provided by the battery. Power is I times V. So in this case, the current that the battery is providing is 0.04 amps. Oops, there's my coffee maker turning off. And the voltage provided by the battery is 24 volts. And so I'm going to do 0.04 times 24. 0.96 watts. 0.96 watts. All right, there is my series circuit. Series circuit. So one loop of current. All resistors get the same current. The voltage, however, has to be split up. Each resistor gets some of that 24 volts. And the way to find the total resistance in that circuit is to add the resistors together. The other thing to notice is that what would happen if if these were light bulbs, if one of these light bulbs burnt out? Well, burnt out means the little filament breaks. And so if this filament broke, oops, I erased it. If this filament here breaks, that means there's a break in the circuit and current can't flow anymore. Everything goes out. If one element in a series circuit breaks, all other elements go out. That's kind of like what happens in your house when your circuit breaker trips. The whole room turns black or turns dark. So, all right, let's go on to a parallel circuit. And let's just use the same battery or the same bunch of batteries. Here's 3 of them. And I'm going to have a 100 ohm for R1, a 200 ohm for R2, and a 300 ohm for R3. R1, R2, R3. There we go. And 24 volts. Now this is different. Same resistors or same light bulbs, if they happen to be light bulbs, the same battery. But when I think about the current coming out of the battery, right here, it has to make a decision. It's either going down to R1 or it's going over to R2. That's a branch. Or a node. All right. Then there's current that comes over here. Some of it goes down. It branches again. Some of it goes over through R3. So what that means is that the current in R1, it might be different from the current in R2, and it might be different from the current in I3. We have to find those values of I1, the current through resistor 1, I2, and I3. And then they add all back together. They add to create the battery voltage. So in a parallel circuit, what's true? The current that is provided by the battery is shared among the resistors. The resistors each get a little bit of that current. Current provided by the battery is shared among the resistors. Okay? Current is shared. You could even say the current provided by the battery is going to be I1 plus I2 plus I3. However, what about the voltage? The voltage that's put out by the battery or provided is given to each resistor. Each resistor in this parallel circuit is getting the full 24 volts. If I look at both sides of this R1 resistor, let me go back to purple. If I look at both sides of this R1 resistor, there's my R1. There's a direct connection to the battery. There's nothing in the way. There's a direct connection to the battery. Look at R2. Here's R2. There's a direct connection to the battery, direct connection with nothing in the way. All right, and same is true for R3. R3 here, direct line to the battery. So each of those resistors gets the full 24 volts. And we said last week, if I wanted to find the equivalent resistance or the total resistance, it's going to be 1 over R1 plus 1 over R2 plus 1 over R3. Gives me 1 over R total. That's true for my parallel resistance. All right. So how can I find these different current values? I1. Well, last week we said we use Ohm's law, V divided by R. And so the voltage is 24 and the resistance is 100. So that's going to be 0.24. So I1 is 0.24 amps. What about I2? The current through resistor 2. Well, that's going to be 24 volts divided by 200 ohms. 24 divided by 200. What's that going to be? 0.12 amps. And I3, 24 volts divided by 300 ohms. 0.08, 0.08 amps. Okay, so let me write this down a little more clearly. So the voltage through resistor 1, 24 volts. The voltage through resistor 2, 24 volts. The voltage through resistor 3 is 24 volts. Each resistor gets the same voltage, and that is the voltage provided by the battery, 24 volts. What about current? Well, in each branch, there's a different amount. Okay, so if I take the voltage and I divide by that resistance, I get the current in each loop, 0.24 amps, 0.12 amps, 0.12 amps, and 0.08 amps. How much current has to be provided by the battery? I need to add those together. So to get the current provided by the battery, 0.24 plus 0.12 plus 0.08, I get 0.44, 0.44 amps. How does that compare to what I had before? So 0.04, my series circuit had 0.04 amps, and my parallel circuit has 0.44, about 10 times more current in the parallel branch. All right. And then last but not least, I could multiply these two things to find the power that's provided by the battery. So current 0.44 amps times 24 volts. 0.44 times 24. I get about 10.6 watts. So there's a lot of power provided in a parallel circuit. All right. And again, we could also find the equivalent resistance. 1 over R total is equal to 1 over 100 plus 1 over 200 plus 1 over 300. So I'm just going to do that on my calculator. You could solve that using fractions if you like. Some people like fractions, others don't. Plus 1 divided by 200. I'm using parentheses here. Plus 1 divided by 300. I get 0.0183 repeating. So that means our total is 1 over 0.0183 repeating. So flip that. 54 ohms. 54 ohms of resistance. Isn't that interesting that in spite of the fact that this parallel resistor has 100 ohms, 200 ohms, and 300 ohms, the total resistance is smaller than any of those. And that's because of the branching. Current has a chance to branch off. So there's less resistance if it has a chance to go somewhere else. All right. The last example I want to do for you is a combo circuit, where we have resistors in series and resistors in parallel.